Hello everyone, and welcome to the video on solving systems of equations. Now this video is going to cover material in sections 8.1 and 8.2. So we're going to kind of do those together, okay? The difference between them is 8.1 is working with 2 equations, 2 unknowns, and 8.2 is 3 equations, 3 unknowns. So let's get started here. Our skill objectives for this video are: number 1, we want to solve systems of 2 variables using substitution, elimination, or graphing. And in number 2, we want to solve systems of linear equations in 3 variables using combination of substitution and or elimination. And then we'll also be looking at application problems. Conceptual objectives here. First, understand that linear systems has one solution, no solution, or infinite solutions. Understand that the graph of a linear equation in 3 variables corresponds to a plane. And 3, be able to visualize the 3 types of solutions in both 2 and 3 variable systems. When solving systems in 2 variables, you have 3 situations that can exist. The first situation that could exist is where the 2 linear functions will cross at one point, in which case we say that system is independent and it has one solution. The second one would be where there's no solution, and in that case, those 2 lines, when you graph them, are parallel, and they would be said to be inconsistent. That would be an inconsistent system. And the third one is where we have an infinite number of solutions, in which case we say that system is dependent. And really what's happening there is that the 2 lines that in the system you're given are going to coincide. They'll be right on top of each other. Now, in terms of solving these things, we have 3 different methods for solving these systems of equations. The first one you'll be familiar with would be substitution. The second one is elimination. And the third one would be by graphing. Now, in terms of these, the 2 that I'm going to look at today are really going to focus, I'm going to focus on substitution and elimination. Graphing gives you a solution, again, because of the accuracy, if you will, in terms of graphing. That can make an issue on how accurate the solution is, or also because it comes out of your calculator, that could be an issue as well too. So our focus, if we want exact solutions, what we're really looking at are going to be using substitution or elimination. Now, just to kind of review substitution and elimination quickly, we're going to start out taking a look at 2 examples. And these are 2 problems that they could ask you to go and solve by substitution. Now, clearly, when you look at the first one over here, this one, that one is much more conducive to solving by substitution because it'd be rather easy to solve for one of the variables. Whereas this one over here, it's not as nice because we're not going to be able to, when we solve for the variable, either whichever one that we do choose, I am going to end up with dealing with some fractions. So let's start out with the first one. In terms of that first one, when I go through and do that, I'm going to go through and I'm going to solve this one, I'm going to solve the top equation here. I'm going to solve it for y. And so to do that, I'll subtract 6x from both sides, in which case I'll get negative y equals negative 6x minus 15. And then if I go through and just multiply both sides by negative 1, I'll get y equals 6x plus 15. And now to solve that system, I'm going to go and take the 6x plus 15 and I'm going to put it into y in the second equation. In which case, when I do that, I will get 2 times x minus 4 times the 6x plus 15 is negative 16. Distribute the negative 4. I have 2x minus 24x minus 60 equals negative 16. Combining the like terms, I have negative 22x minus 60 equals negative 16. Adding 60 to both sides, I'll get negative 22x equals 44. Divide by negative 22. I get that x equals negative 2. And then to solve for y, I just go back into what I originally had here when y equals 6x plus 15. And I can say y equals 6 times negative 2 plus 15. So y equals negative 12 plus 15. So y equals 3. So now what I would need to do is just check that. Put negative 2 in for x and 3 in for y into each equation. So I'd have 6 times negative 2 minus 3. That does equal negative 15. And then I can take 2 times negative 2 minus 4 times 3. And that's going to be negative 4 minus 12. And yes, that will equal negative 16. So in this case, both check. And so I know our solution here is going to be the point, negative 2, 3. Now let's take a look at this second system. Now in that one, as I'm looking at it, I'm looking at that problem and I say, they want me to solve it by substitution. And I want to solve it so I have to deal with fractions at the smallest amount of time. And to do that, it's going to be by going through and taking the second equation and dividing everything by solving it for x. And so when I do that, I will get, first I'll subtract 8y. I'll have 3x equals negative 8y plus 30. And then divide by 3, I get x equals negative 8/3 y plus 10. So now I'll go back to that first equation. I'll take the negative 8/3 y plus 10, plug that in for x. So I'll have 4 times negative 8/3y plus 10 minus 5y equals negative 7. Distribute the 4. I'll get negative 32/3y plus 40 minus 5y is negative 7. Subtract the 40. I have negative 32/3 times y minus 5y equals negative 47. Get a common denominator. Think of that as over 1. Get a common denominator. That's going to be negative 32/3 minus 15/3 times both of these times y equals negative 47. And then when I do that, that's going to be negative 47/3 times y is negative 47. And then solving that for y, multiply both sides, in this case, by negative 3/47. What I'm going to get is y equals 3. So now I know y is 3. I can now solve for x. I plug 3 in for y. I know x then is going to be negative 8/3 times 3 plus 10. In which case, when I do that, that's negative 8 plus 10, which is 2. So my solution here on this one comes out to be 2, 3. And again, I would need to go through and check that. So I'd plug 2 in for x and 3 in for y to make sure that it worked. And if you do that real quick, you'll notice that it will work. It does check out. If you put 2, 3 into this equation, I'll get 8 minus 15 does equal negative 7. And if I put 2 and 3 into this equation, I will get 6 plus 24 does equal 30. So that does work out, and then that would then be my solution. Now let's review elimination. And keep in mind, with the substitution that we just saw and with the elimination, if there's any questions that you have, make sure to note those and ask about them in class. Elimination, though, I tend to use elimination more often than substitution. Mainly, me personally, I think it's easier. But it is up to you in terms of doing these things, unless it's spelled out to go through and use substitution or use elimination. You may use either one of those methods, whichever one is most comfortable or seems the easiest to you. Now, in this case, when I look at a problem with elimination, the main idea is that I have a system. I want to rewrite the system by multiplying one or both of the equations by an appropriate constant, so that I will get that either the coefficients on the x's or the y's will be opposites of each other. Now, sometimes it's set up for you already, like look at example 1. In the next one, we're going to have to actually go through and deal with both equations. So in the first example, that one is already set up for elimination, because if you take a look on that, you'll notice that it is a negative 2x and a positive 2x. So by just adding these two equations together, the x's are going to be eliminated. And so what happens on that, I go through and I'm going to add those up. And when I do it, negative 2x plus 2x, that's 0. 3y plus y is going to be 4y. And 1 plus 7 equals 8. So in that case, divide by 4, I get y does equal 2. And now I have to just pick one of the other equations to solve, to plug that into. So I'll put it into the second equation. I think that would be easier. So using that second equation, I have 2x plus y, which we know is 2, equals 7. So 2x, by subtracting 2x is equal to 5, and x equals 5 over 2. And then the last thing you'd want to do would be to check your solution. And to do that, you just have to go back into the first equation, the equation you didn't use to find that second variable. So in this case, to find x, we used this equation here. So to check, we're going to use that equation, the negative 2x plus 3y. And so to do the check on that one, I take negative 2 times 5 over 2 plus 3 times y, which is 2, and show that equals 1. Well, that's going to end up being negative 5 plus 6. That does equal 1, so it does check. So our solution on this one is going to be the point 5 over 2, 2. Now, with the second system, in that situation right there, I have a little issue, because neither of my coefficients, either on the x's or the y's, are opposites, and really neither of them are multiples of the other. So in this situation, what I'm going to have to do is I'm going to have to go and multiply top and bottom by the first equation 1 and equation 2 by something, so that I will have coefficients that are the opposite. And probably in my mind, because the y's are already opposites, I have a negative 2y and a positive 5y, it's going to be easier to eliminate the y's in this one. So to do that, I'm going to multiply the top equation by a positive 5, and I'm going to multiply the bottom equation by a positive 2. And so when I do that, I will get that first equation will become 25x minus 10y equals 35. And my second equation is going to become 6x plus 10y equals 2 times 29 is going to be 58. And now we add those up. That's going to be 31x equals 93. Divide by 31. And I get x equal to 3. Now I need to solve for y. And again, it really doesn't matter which one I work with. I probably will work this time with the second equation, because it does have a positive 5y instead of a negative. I'm not, the less I have to deal with negative signs, the better off I'm going to be. So I'm going to take that second equation. So I'll get 3 times 3 plus 5y equals 29. So that's 9 plus 5y equals 29. So I get 5y equals 20, so y equals 4. So my solution right now is the 0.34. And so the only thing I have left to do now is to check it. And again, we'll check it by using the other equation, which in this case, again, like the first time, is the top equation. And so I take 5 times 3 minus 2 times 4. And I want to show that 7. Well, that's going to be 15 minus 8. And that does equal 7, so it does check. And therefore, our solution is 3, 4. So that really kind of reviews the substitution elimination. I'm not going to spend time reviewing the graphing because I think you can all do that. But keep in mind, if I want you to find a solution, unless I tell you to do it by graphing, I'm going to expect substitution or elimination. Now let's look at what happens when we're solving a system of 3 variables. Now in these, when you have 3 variables, now what you're dealing with, the equation that you have really does represent a plane, okay? And really what we're finding then is, instead of like when we were in two dimensions or 2 variables, we were finding a point, the point of intersection. In this case, we're finding the intersection of 3 planes. And really what can happen in that case is that the 3 planes, if there's one solution, it means that they only intersect at one point. And that would be in this situation here where we have one solution. The solution is that point where all 3 planes come together. Now, when we have no solution, we have a couple of different situations that can happen here. What we can have are where the 3 planes are parallel, so they never intersect. So that's something that you could have. But the planes may not be parallel, but they may not have a single point in common, which is a situation that's happening here, okay? You have the blue and green intersect there, the red and green there, and the blue and red there, but they don't all 3 come together at the same spot, okay? And then the third thing is where there's an infinite number of solutions, in which case the 3 planes come together. Now what you have to keep in mind is that when 2 planes intersect, they form a line. So in this case, it's when all 3 planes come together and they all intersect with the same line. They form that line of intersection. And so that's when you're going to have an infinite number of solutions. Now your process for going through and solving these things. Okay, the first thing you're going to want to do is you're going to reduce the system to 3 equations and 3 variables, to 2 equations in the same 2 variables. That's the one key thing. You want to make sure that if you reduce one to x, you're going to make one equation of x and y. You're going to have to do the same thing with the other. But you're going to do that by applying elimination. And you're going to take, the way it's going to work, you're going to take like equation 1 and equation 2, and maybe equation 2 and equation 3, go through and eliminate the same variable with those. Any combination of those like that. Step 2, you're going to solve the resulting system of equations in 2 variables by either substitution or elimination, whichever way you want. In other words, you're going to take, step 2 is just what we did in the last 2 slides, where we went through and said, oh, this is substitution, this is elimination. You're going to have the choice of which one you're going to do. Step 3, you're going to take the solutions that you got from step 2 and plug those values into any of the original 3 equations, whichever one, and you're going to solve for the 3rd variable. So in that case, like step 2 is going to give you the values for 2 of the 3 variables. Step 3 will give you the value for the 3rd variable, but now you'll still have 2 equations that you haven't plugged into. The 2 of the original equations that you haven't worked with, you're going to plug your solution into the other 2 original equations, and you want to show that that will make that true. And as long as it makes both of those your solution makes both of those equations true, then you know that is actually the point of intersection of that of the plane. If it doesn't make one of those true, then there is no solution, okay? And we'll show you also what will happen when you have an infinite number of solutions. Now, here's an example where we end up with a single solution. Okay, now it starts out here. We're given equation 1 is x minus 2y plus z equals 0. Equation 2 is negative 2x plus y minus z equals negative 5. And equation 3 is 13x plus 7y plus 5z equals 6. And now what I'm going to do is I want to go and eliminate one of the variables. And the variable I'm going to choose to eliminate on this one is really I'm going to eliminate the z's. So it's going to be real easy to eliminate the z's by using equation 1 and equation 2. So that's what I do. I take equation 1, put it here, equation 2 here, and then I just add those up. So when I add x minus 2x, I get negative x. Minus 2y plus y is minus y. The z's cancel out, and I get negative 5. And what I did to make that easier is I just multiplied this by negative 1, and so I have x plus y equals 5. So that's one of the equations that I have. The next one I have is I want to eliminate z, and to do it, I'm going to use equation 2 and equation 3. So in this case, I had negative 2x plus y minus z equals negative 5. And 13x plus 7y plus 5z equals 6. Now to eliminate the z, I need to multiply this top equation here, that equation, by 5. And so by doing that, when I do that, that gave me negative 10x plus 5y minus 5z equals negative 25. And 13x plus 7y plus 5z equals 6. And when I add everything up, I get 13x plus 12y equals negative 19. So now I have my two equations. I've reduced this system here down to two equations and two variables. And that's what I have up here. And so I want to get rid of one of them. I can choose to get rid of either one. In this case, I chose to get rid of the y. Okay? So to get rid of the y, I'm going to multiply the top equation by negative 12. That's where that negative 12 comes from. And when I do that, I'll get negative 12x minus 12y equals negative 60. And this equation just comes over. 3x plus 12y equals negative 19. And so when I add things up, I get negative 9x equals negative 79, or x comes out to be 79 over 9. Now I have to solve for y. To do that, I'm going to use this equation. I know x is 79 over 9, just like we normally did with substitution. I'm going to put that into that equation. So 79 over 9 plus y equals 5, which I know is 45 over 9. So y is equal to 45 over 9 minus 79 over 9, which comes out to be a negative 34 over 9. So now I have x is 79 over 9, y is negative 34 over 9. And I now need to solve for z. And again, I just have to pick one of these three equations to solve for z, to find out what z is. And the one I'm going to choose to use is the first equation. So I have x minus 2y plus z equals 0. So x is 79 over 9 minus 2 times y, which is negative 34 over 9, plus z equals 0. So that's 79 over 9 plus 68 over 9 plus z equals 0. When I add those up, that's 147 over 9. So I know z is negative 147 over 9, which reduces to negative 49 over 3. And so my solution point right now is 79 over 9, negative 34 over 9, and negative 49 over 3. Now I have to check that. I check that by plugging these values for x, y, and z into equations, into my other two original equations. So negative 2 times 79 over 9 plus negative 34 over 9 minus a negative 49 over 3. I just put that in the calculator and show that it equals 5. And same with equation 3. 13 times 79 over 9 plus 7 times negative 34 over 9 plus 5 times negative 49 over 3. Plug that into the calculator and show that that does equal 6. It will check out, and this right here is our solution. So the key part on this, when you're solving that system, the main goal, your initial goal, is to reduce that system down to a system of 2 equations and 2 unknowns. So that's what we were doing right over here, and then it was solving that system from that point forward. At this point, pause the video, make sure you're comfortable with everything I did. There's a lot of work on this one. Make sure you're comfortable with everything I did, and if you have questions, make sure to ask them in class. Now let's take a look at another example. In this case, what we have here is we have 3 equations, x plus 2y minus z equals 3, 2x plus y plus 2z equals negative 1, and negative 2x minus 4y plus 2z equals 5. And again, I want to go through and eliminate one of the variables. In this case, I chose again to eliminate z. You could go through and choose to eliminate x. It doesn't matter which one you choose. In this case, I eliminated z. So to do that with the first and second equation, I needed to multiply the top equation by 2. And when I did it, I had 2x plus 4y minus 2z equals 6. And 2x plus y plus 2z equals negative 1. And when I add those together, I get 4x plus y plus 5y equals 5. When I take equations 2 and 3, again, I want to eliminate the z. Right there, I have 2x plus y plus 2z equals negative 1, and negative 2x minus 4y plus 2z equals 5. So in order to eliminate the z's, I need to multiply one equation by a negative value. And when we do that, we multiplied, I just multiplied the bottom equation by negative 1. And so I got the 2x plus y plus 2z equals negative 1. And then when I multiply this bottom equation by negative 1, it's now positive 2x plus 4y minus 2z equals negative 5. And I get 4x plus 5y equals negative 6. So now you'll notice something right away with this. I had my 2 equations, 4x plus 5y equals 5 there, and 4x plus 5y equals negative 6. In that situation, we can go through solving that system by elimination. We can just multiply that second equation by a negative 1. And when I add it up, I'll get 0 equals 11. In that situation, that's not true. So therefore, there is no solution. So in this case right there, this is a false statement. Okay, and so therefore, this system has no solution. Okay. Again, pause the video, make sure you're comfortable with everything that I have here. Once you are, let's move on. Now, in this example, what I have is x plus y minus 2z equals 0, x minus z equals negative 1, and x minus 2y plus z equals negative 3. Now in this case, I'm already set with an equation with just 2 variables with equation 2. So I'm going to choose to get rid of the y. I'm going to use a combination of equation 1 and equation 3 to get rid of the y's. So what I did is I took 2 times equation 1 plus equation 3. So 2 times equation 1 is 2x plus 2y minus 4z equals 0. And equation 3 is x minus 2y plus z equals negative 3. So when I add it up, I got 3x minus 3 equals negative 3. Or dividing everything by negative 3, I get x minus z equals negative 1. At that point, you're going to notice here, equation 1 is x minus z equals negative 1. That's here. And then this equation is right here. They are exactly the same. So when I try to do this by elimination, what's going to end up happening, I'll get there, make that a plus, and I'm going to end up with 0 equals 0. In that situation, that tells us right now that our solution is an infinite set. In other words, we are going to go through the planes. The 3 planes are going to intersect to form a line. And now we want to find a solution that is general. That's going to be in terms of a parameter. And a lot of times the parameter that the book uses is a. So what I'm going to do on this one, in this case, I'm going to let z equal a. Now you can choose to let whatever variable, whichever one, x, y, or z equal to a. It doesn't matter. But I'm going to choose, in this case, to let z equal a. So by working with that second equation, I know x minus a equals -1. And then when I solve for x, I'll get that x equals a minus 1. And the next thing I have to do is solve for y. So again, I can use whichever equation I want here, and I'll use the first equation, x plus y minus 2z equals 0. Well, I know x is a minus 1 and z is a, so I'm going to get a minus 1 plus y minus 2a equals 0. Combining the like terms, I get y minus a minus 1 equals 0. Solving it for y, I get y equals a plus 1. So in this case, my solution now is a minus 1, a plus 1, and a. I can find solutions by putting in numbers for a, any value I want. If I want to put 10 in for a, I would get 9, 11, 10. That would be a solution on this one. Or I could put in -5 in for a. If I put -5 in, I'd get -6, -4, -5. That would also be a solution. This is a general point that represents every solution, the infinite solutions to this system. And again, the last thing we still have to do, we still want to check that. We got equation 2. We used equation 2 to find this, but I did put that one there. And then equation 3, x minus 2y plus z, so a minus 1 minus 2 times a plus 1 plus a equals -3. Distributing the -2, and I get a minus 1 minus 2a minus 2 plus a. And if you combine the like terms, you'll notice that, yes, that does check. And so our solution to this system, the infinite number of points that satisfy this system, this right there. So this does conclude the video covering 8 through 8.1 and 8.2. So again, make sure that you are ready for some questions. We'll take a look. We'll look at a story problem in class. And but with that, we will see, make sure you have your questions written down, and we'll see you in the next class.